Assalamu alaikum. Welcome to the CSITEd Experts Data Science A to Z Bootcamp. I am super excited that we have started developing our machine learning model with simple linear regression model. In the previous two videos, in this video, I discussed how to develop a simple linear regression model using sklearn library, and in this video I discussed how to develop a single linear regression model using self-calculated regressor in Python. So the red line here is my regressor line that we developed with our simple experience versus yearly salary data with our training set, and on the right side is our regressor model that we validated our same regressor model using the test set. And first time we developed this using sklearn library, and later we developed this using self-calculated beta. The formula is here. Once we find the beta, then it is easy to find y as a predicted y equal to x transpose b. So since it may be confusing to many of you, so I am waiting to discuss in the theory sections how to develop this regressor in a few lecture videos. But before that, in this video I want to discuss something more about our self-calculated beta value and the advantages of our model, of our new model. Let me quickly open my program, which one I want to discuss right now. So this should be a good program that if we discuss right now. Okay, so let me clean everything. Okay, so in my simple linear regression folder, so let me open the folder. In my simple linear regression folder, you will see regression, simple regression folder. You will see I have a comparative salary data CSV file. So this is my comparative salary data CSV file. Okay, so if I open this CSV file, data file, you will see that I have the same previous 50 salary information of an employee, some pseudo employee of a pseudo company. So the first column I have years of experience here, experience in year, and the last column the annual salary. These values, the first columns and the second column, these values are exactly same with our express exp salary data, but in addition to this I have some extra columns like education, performance, dedication, language learned, gender and ethnicity, this information. For instance, let us assume that a company keeps information or determines their employee salary based on their life, based on the employee's experience and total years of education, performance, dedication to the company. Okay, let us consider that performance is scaled from 1 to 5 and dedication to company is measured in a scale 1 to 10, and how many languages an employee knows, and maybe gender, maybe we are considering here, we have here 0 for male or 1 for female or vice versa, whatever, and maybe maybe with ethnicity, for instance Asian American, mm, African American, or South American, maybe. We are not segregating, but we are not, but just assume in order to develop an extended linear regression model. And this salary column, this annual salary column, actually this value depends on all of these are the independent variables. These columns, these 7 columns, 1 2 3 4 5 6 7, these 7 columns are the independent columns, independent variables, and this is the only dependent variable. Okay, so that means this salary depends on the combination of all of these independent values. Similar. Okay, so let's get started. So let's import the libraries. Okay, libraries are imported, done. So let's import the data. Okay, our data set is imported. So we have here 50 column, 50 rows and 8 columns. So let me show you again the same data we have. So index 0 to 49, so there are 50 rows and 8 columns. Okay, that's good. So let us assign the x, the matrix x, as a matrix. Okay, so I got this is with 50 columns and wall 7 with 50 rows and wall 7 columns with independent variables. Okay, and let us get y as is the dependent variable. Okay, so that is actually here, and let me explain it again. So 0 to 7, that means, okay, 7 is excluded. Okay, 0 to 7, okay, 7 is included here. 0 to 7, that means 8, oh no, 7 columns. So 0 to 7, 7 is excluded, so that means 0 to 6. Okay, so in that case we are giving 7 columns, but you cannot write this way 0, or you cannot write this way 7. It will not work. Okay, and here my dependent column is only 1 column, but we will write this way 7 to 8, column 7 to 8. Okay, column 7 number is included but 8 number is excluded, so actually this will be only 1 column. Okay, you see that I have only 1 column. So here, so note that, as I also mentioned, so since y is a transpose matrix, you cannot write this way. You cannot write this way. Okay, and if we print x, then you will see that I have my x data, and if I print y, then you will see this is my y data. And as I discussed in one of our previous videos, how to develop the regressor, here the regressor, in order to develop the regressor, I have to calculate x whole inverse, then xt, then y. These are, all of these are matrices, so we need to do a lot of matrix calculation. So here are the matrix calculation. My x is there, and my x transpose is here, and okay, sorry, I need to run this. I need to execute this. My x transpose, we are using numpy library, so this is easy to make a transpose matrix by using numpy. So np dot transpose x, so that then x transpose x, okay, then x transpose x whole inverse, and then x transpose x whole inverse into x transpose. This is my regressor. Okay, my regressor is matrix of x transpose x whole inverse times x transpose times matrix of y. So this is my regressor. At this point, if I print x, then I will get my x, I will get my x transpose, I will get my x transpose x, I will get my x transpose x whole inverse, I will get my x transpose x whole inverse times x transpose, and I will get my regressor here. You see my regressor over here. How many is my regressor has one column but multiple rows. How many rows I should have? Can you think how many rows I should have? It will depend on how many columns I did have in my independent data set. My independent data set had 7 columns, right? So I should have 7 independent regressors here. 1 2 3 4 5 6 7. Okay, that's good. I got my regressor is correct. So now if I get my regressor, now then it is easy to find any predicted values for any feature value. For instance, this, if this is my feature value, x is my feature value, then I need to get x transpose, this feature matrix transpose, times my beta, my regressor calculated, then I will get, so the value over lines this parallel to this line. So that will be my predicted y. So then it is pretty simple. So for instance here, since let me go it again, in my independent data set, you see it, my x, okay, it has, my x has 0 to 6, that means 7 columns. If you remember that the first column is for let me go from my data set. Okay, let me do it side by side. The first column is my experience column, so the first regressor is for experience, and the second column as the independent variable of year of education. So the second regressor will be for education, and the third one was performance. So this third one is the regressor for performance, and the fourth one is dedication. So this is for dedication, and the fifth one is language. So this is for language, and so on. So now once I have my regressor ready, then for any kind of feature data, for instance, if I am given any set of in this row here I provide as a feature, then I can calculate the corresponding predicted y value. Okay, so by using this very simple calculation, so here my predicted x predicted is, that means 4 years experience with 14 years of total education, and 3 is the performance scale value, and 5 is the dedication to the company, and 1 is maybe the language known, and 5 is this one is male or female, and this was ethnicity. Okay, so then if I calculate my y predicted y like this, y equal to, so matrix, feature matrix, and so since I am giving my feature matrix this way, it is already a transpose matrix. It is already transpose. You know that a vector always have one column and multiple rows. So when a vector is transposed, then that becomes a one row and multiple columns, right? So this is already a transpose. So then once I execute this, I will get this predicted y, okay, for this independent data set, 4 years of experience and 14 years of study, and so on. Okay, similarly if I execute my this set with 6 years of experience and 16 years of total education, then my, and so on, and then my predicted value is, predicted yearly salary will be 80,900, and similarly so on, and similarly for 8 years of experience and 12 years of total education, and 5 is the performance, and 10 is the dedication, and 2 languages known, my values will be, my y predicted will be 108,000. Okay, so that's it. So here the pretty tricky part here is to calculate the regressor, but once you understand how to calculate the regressor, and then it will be very simple for you. So in the corresponding theory section, I discuss how to calculate this regressor step by step. So then once you understand how to develop this regressor step by step, then the entire process will be crystal clear to you. Now I want to, so I like you to do practice and do this practice, and I also want to give you a homework. The homework is that in the data, in the regressor, in the simple linear regression, in this folder, you will see there is a dummy Titanic data set, CSV dummy Titanic data. If you open up, you see that it has okay, 1 2 3 4 5 6 7 columns of independent values, and 1 column is dependent values. Okay, the ticket fare is dependent values. So this problem is pretty simple with my with the comprehensive salary data. So almost same, but so I like you to do practice. I like you to practice. Remember that the only practice will make you perfect. So as I want to I like you to work for the homework, and that's just, I have a quick questions. So can we draw this scatter plot or the plot for this with this this data, although I have this running and working, I have x and y, I have x and y over here, and I got my regressor, and I am getting my predicted values. But can we visualize this regressor model as a chart? Let us run this and think about a second. Although we have x and y values, so can we develop this? No. Okay, the reason is that here you see that although we tried to visualize this, it is coming as a blank, because the reason is that here, think about that, my independent data set is multi-dimensional. How many dimensions I do have? That means how many columns I do have in my x. I have 7 columns. That means my 7 dimension. Okay, in my previous problem, that what we discussed in this program. Okay, if I run this program, you would see that we developed this kind of regressor model, because it has only, okay, so my this independent this data set as row and columns and 2-dimensional, only experience and salary 2-dimensional, right? But here I have experience. In my data set I have experience, education, performance, dedication, language, and like, for instance, I have a total of 7 dimensions. So we cannot display 7 dimension in a 2-dimension scale, right? So this is why it will not be possible to display a grid or display a scatter plot, or plot with this data. Actually, this is the limitation. If you remember that, I asked you to think about the limitation of this model. So this is one of the limitations of this model, but it is very convenient that with this model we can use any number of data set, any kind of data set, to build our to find or calculate our predicted value, to build our regressor and to build our predicted value. So I could take any, like, 3 columns over here. Okay, I could take 3 columns over here. Then if I take 3 columns over here, then I will have only 3 values, first 3 values in my feature. So this number of columns, it will be 7 columns over here, and these values will be 7 values. This should be matched. Okay, so now I like you to practice with some subset of, by taking subset of this matrix. So for instance, first take this one and this one, this one and this one, or this one, or this column, and this column and these columns with different combination, and then you will have a good practice how to build your data x value with different columns of independent values, but your y is the dependent variable. Here is always will be like this. Thank you so much. Thank you for watching this video, and I believe at this point you should get some interesting information, and it will be a good starting point to practice developing machine learning model with Python. Thank you so much. Thank you for joining with me in our data science learning journey. Thank you so much. Bye bye.